Okay guys, mathematical logic is best understood with all these parameters in mind. Alright, so we have seen four connectives. We have seen these four connectives already. These are three prime components which we would be dealing with. We saw conjunction. In conjunction, that is what is and best understood with series circuit. Disjunction, or represent this way, best understood with parallel circuit. Implication or conditional is represented this way, and truth table for conditional we found that when T conditional F or T implication F only is F, rest all are T. Alright. In case of double implication or biconditional, we find T, T, F, F biconditional are true, rest all are false, rest other two they are all false. Okay, so that's what we saw. Negation is just this sign. Tautology, when the result are all T, that is tautology. Contradiction, when results are all F, that is contradiction. Contingency, neither true nor false. Okay, that is it. Now, negation of compound statement, that also is very much essential for us to know. Negation of conjunction. Negation of conjunction, when we open the bracket, this is somewhat like x plus y in a bracket, and you are multiplying that bracket with negative. Alright, so this becomes negative, that becomes negative. So similarly, somewhat like that. So this is negation, this is and. So negation comes to this, negation comes to that, and converts to or. Similarly, negation for disjunction, same story. Alright, this which is there or which is there gets converted to and. Alright, negation of implication. In case of negation of implication, see P remains as it is, then we get and negation of the next one. Alright, that's what it is. Negation of double implication, this is what we get. So when negation gets into double implication, what happens is, first it is P and negation of Q, then comes or, then again comes Q and negation of P. Alright, alternate. Here it is P, here it is Q, and negation Q, negation P, and between. Then Q conditional P is converse of P conditional Q. Negation of P conditional negation of Q is inverse of P and Q. Alright, so got the difference here. Here is Q and P, here is negation P and Q. Both are, so just negation. So as soon as we put negation, this shifts over here. Fine. Negation Q, conditional negation P. Now here it was negation P and negation Q. Here it is negation Q, conditional negation P is contrapositive of P and Q. Then again, the pattern of truth table. Now if we have only two prime components, alright, if only two prime components, then how do we represent? We put TT, FF, and then TF, TF. Now if we have three prime components, then P, Q, R represent that way. Then we put 4 T's, 4F, then 2 T's, 2F, 2 T's, 2F, and the third one, last one is TF, 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 TF. This is the pattern which is we followed when we form truth table with either two prime components P and Q or three prime components P, Q, R. Alright, so these are the things which you have got to have in mind. Some more are there which I would again represent in my other video. Okay.